Hello student, so I hope you all are doing well. So welcome all, and today we are going to discuss very interesting topic today. So today we are going to talk about the Kirchoff's law, and in this particular class we are going to talk about the Kirchoff first law. First, let's talk about कि हम क्यों use करते हैं Kirchoff's law का. Whenever we are having the complicated circuits and हमें उनको solve करना होता है, so we can use the Kirchoff law to make it simple. Let's start with the first law. So, talking about the Kirchoff's law, Kirchoff in 1842 formulated the following two laws that enabled us to find the distribution of the current in a complicated circuits. So, the distribution of current in a complicated circuits, we are able to do it with the help of Kirchoff laws. The very first law which we are going to discuss here, that is known as Kirchoff first law, also known as junction rule and also known as Kirchoff current law. So here what this law says that, this law states that at any junction the sum of the currents entering the junction is equal to the sum of the current leaving the junction. I hope it is clearly visible to all of you. So very simple, it is saying that कि जो भी करंट एंटर कर रही है एट ए जंक्शन वो इक्वल होगी जितनी करंट उस जंक्शन से बाहर निकल रही है. So let's understand this with the help of some examples. So here it is example, you are able to see that I1, I2 are the currents which are entering in the circuit and I4 and I3 are exiting from the junction, not the circuit, from the junction, right? So as we talked about that, the current enter in a junction must be equal to the current leaving the junction, right? So current enter here, if I'm talking about, that is I1 and I2, so I can write it I1 plus I2, that must be equal to the current which is leaving the junction. So here if you see carefully, that is I4 and I3, they are leaving, so I can write it I3 plus I4. So basically I1 plus I2 minus I3 minus I4, that must be equal to 0. From this expression which we are getting here, we can define this law again. How we can define it? So we can say it like that, when we are getting I1 plus I2 is equal to I3 plus I4, or I1 plus I2 minus I3 minus I4 is equal to 0, we can say that the algebraic sum of current at a junction is 0. What is this? We are finding the algebraic sum of the currents, right? I1 plus I2 minus I3 minus I4 is equal to 0. So we can also state it like that, the Kirchoff first law also stated as the algebraic sum of current at a junction is equal to 0. Kirchoff first law is in accordance with the law of conservation of charge. You can clearly see that when we are talking about that, the algebraic sum must be equal to 0 here. So with the help of this, we can easily say that it is based on the conservation of charge. The conservation of charge can neither be created nor be destroyed. It is definitely constant in the universe, right? It is constant basically. Now let's see some more examples here. In this example again we can see here I1 current is entering, I3 is entering, I2 is entering, and I4 and I5 is leaving the circuit. So I1 plus I2 plus I3 must be equal to I4 plus I5. Simple as that. Let's solve one question on the basis of that. Using KCL, which is also known as Kirchoff current law, to determine the value of unknown current in the circuit below. Here we need to find out the value of unknown current in the circuit. So we are able to identify a junction here, which is blue in a color. And if you see that 4 ampere current is entering and 2 ampere current is exiting, and minus 1 ampere current that is also exiting the junction, and I is also exiting the junction, right? We need to find out the value of I. So class, 45-second time you all are having. Quickly try to solve it and let me know the answers in the comment box. Quickly everyone. Time is up. I hope you all got the answer for that. Let's see that. Did you got the right answer or not? 4 ampere current that is entering in the circuit. Let's just a minute. Four. Any other current which is entering in the circuit? No. So 4 ampere must be equal to -1 because that is leaving the circuit. Same as well 2 ampere and the I. The value of I we need to find it out, right? So 2 minus 1, that will give -1, right? Okay, fine. So just a minute, let me check it once again. Yeah, it will give you 1 ampere. So 1 plus I must be equal to 4. So the value of I will be equal to 4 minus 1, which is 3 ampere. The units are very, very important. So when we are talking about the units are also very important. Okay, so that is the first law of Kirchhoff, which is also known as the Kirchhoff current law, the junction law, and the Kirchhoff first law. So in the last, let's see it again. Basically, it says that at any junction, the sum of the current entering the junction is equal to the current leaving the junction, which also means that the algebraic sum of current at a junction is equal to 0. And it is based on the conservation of charge. In the next class, which is the upcoming video, what we are going to talk about, we are going to understand about the Kirchhoff's second law, which is also known as Kirchhoff voltage law and the loop rule. So stay here with us. We will come soon and we will talk about the Kirchhoff's second law. Till then, practice these questions, and if you are having any confusion, any doubt, let me know in the comment box. Thank you all.